And finally, the last example in this section, they give us an equation, 1 over x squared, and they give us the parent graph or the original graph to the right. This wasn't one on our sheet. This is a new one. So we need to be able to do all of the graphs that we can using the patterns that we've noticed. So, for A, first of all, for A, I would take the time to keep the y by itself and move the 3 over. And this question says, describe. There's been a big push in the last 5 years to use more words in math. And lately, hasn't really worked, but there's also been a push to use more numbers in English. I don't think that's happened very much yet. But they want more of both of those things in all subjects. So the more words in math, they want you to describe what's that 3 going to do? The graph of y equals 1 over x squared will be translated 3 units up. So I like to put the 3 on the right-hand side in order to describe it. So describe, create each function below. I've described it. Second part of this question, what are the equations of the asymptotes of each image graph? So this is the original graph. It has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Equations of horizontal and vertical lines is sometimes something that students mix up. Does it bother you that the y-axis is labeled as x equals? Okay? Does it feels weird that way? Or that the x-axis is labeled as y equals? How do you know how to label them? Why is it labeled that way? So if you took on your y-axis and randomly labeled 4 or 5 points, you don't have to write this down, but just to watch. Like if I pick this point, would you agree that that point is 0, 2? And this point is 0, 4. And down here I'd have 0, negative 1. And if I kept doing that and I said, what's in common in all of those points? The thing that's in common is that the x-coordinate always equals 0. And that's why vertical lines are always x equals. Because what's in common in all those points? Well, x is always the same number. Same thing with horizontal lines. If I label any point on my x-axis, the y-coordinate is always 0. That's why you have those equations. So if in the past you were trying to memorize, these ones are x, these ones are y, it's so much easier in math if you memorize things that make sense. Okay? It's true with anything, right? It's a lot easier to remember something if it makes sense. If you're trying to remember something and it's not making sense to you, you're going to have a much harder time remembering it. So I'm going to try, whenever I see opportunities, to try to make things make sense. So hopefully you can remember them easier, and that makes your math class easier as a result. So now the question here was, if you move it 3 units up, the new asymptotes what will they be? Well, moving things up, can you see that your vertical one will stay at x equals 0 when it gets moved up? But your horizontal one will now be at y equals 3. And for part B, again in part B, I would take the time to rewrite it. And if I compare the equation that I have here to the original equation, the original equation had an x squared on the bottom. Now I have an x plus 3 squared on the bottom. The original equation didn't have anything after. Now I have a minus 4. So if I was describing this, this graph of y equals x squared, 1 over x squared, will be translated. The 3 will move it left or right? Left. Right? Anything inside the function is opposite of what you see, so that'll be 3 units to the left. And the 4, because it's a minus, will go 4 units down. For part B, your new asymptotes? Well, if you move 3 to the left, that will change your vertical one. It will now be at x equals minus 3. If you move 4 down, that will change your horizontal one. It will now be at y equals minus 4. So this question, you can now do number 16 and 17.